And there we go. Okay, so lesson 1.2, factor by grouping, is what we need to cover today. Now, this is the only method you will ever have when you see four terms together. Okay, so when you see something like this with four terms, it may or may not factor, but if it does, the only method you have is factor by grouping, which is what we're about to do. So if you see two terms with it subtracted, what's the only, well, we got two methods. What could work? What are the only two? It could be the difference of squares, or it could be greatest common factors. So first of all, greatest common factor could work anywhere. Okay, so that could apply to anything. But then if you've got two things that are perfect squares subtracted, that's difference of squares. Two things added, difference of squares will never work. But if you see four terms, and I have hopes of factoring this beyond greatest common factor, the only thing is going to be grouping. Okay. Now all grouping is, it's taking the greatest common factor and doing it two times. Okay. So all you have to do is break this into two problems. So if I look at this and I look at this, all grouping really is saying, can I find a greatest common factor in the yellow? And then can I find a greatest common factor in the cyan or the blue here? So let's look at the yellow. What is the greatest common factor between 6 and 21? 3. Okay, so I'm going to write 3. And then if I look at a y cubed and a y squared, what do I have in common? Y squared. Okay, now let's construct it to where I factor that out. What do I multiply 3 by to get 6? That's 2. What do I multiply y squared to get y cubed? Y. Okay. What do I multiply 3 by so I get 21? 7. Okay. And then what do I multiply y squared by to get y squared? That's 1. Okay. So that's half of the problem right there. Okay. Now, the next thing you see is a minus sign. Write it down. Okay. Now, let's pretend like this is a totally new problem. What do 4 and 14 have in common? 2. So if I factor out a 2, what do I multiply 2 by to get 4? That's 2. And then I have to multiply here by a y. And then here's where we get a little bit tricky. So I've got this minus sign. So it was minus 2 times 2 gives me minus 4. Now, what do I have to multiply in minus? This is a minus 2. What do I have to multiply in minus 2 to get a positive 14? Negative 7. Here I am thinking you guys are going to miss that, and you're right on top of it. Okay, there we go. Now, what do you see? So what do you see anything that looks same in both spots? 2y minus 7. So now I can factor out the 2y minus 7. The 2y minus 7 occurs in both places. So it's sort of a two-step factorization. I factor this and this, and now I've got to this term, and I see this is in both places. So I can factor this out. So this would be 2y minus 7. And you could just cover it up. If a 2y minus 7 went missing here, what would I be left with? 3y squared. Okay. If a 2y minus 7 went missing over here, what would I be left with? Negative 2. Okay, that's it. Okay. I know it's a little bit tricky. So if you look at it, what if I had something like this? If I had 3y squared x minus 2x, okay? You would say, what do I need to factor out of here? What can I factor here that's in both places? X, okay? So instead of an x, I've got this parentheses 2y minus 7, 2y minus 7. So when I get to this point, what do these expressions have in common? They both have a 2y minus 7 in them, okay? So if I pull the 2y minus 7 out, I'm left with 3y squared minus 2, okay? So 2y minus 7, 3y squared minus 2, okay? So it's really like it's like a three-step problem. You look at the first two things, find the greatest common factor. Look at the second two things, find the greatest common factor. If you've done it right, then inside your parentheses, you should see the same thing in both places. Now you factor it again, saying, okay, well, take out what's in the parentheses there, and I'm left with 3y squared minus 2. Yes? Right. The whole point, if grouping is going to work, you're going to get in parentheses two things that match, and then you can factor it again. Yes, Olivia? okay, because this line follows from here. So if you look at it, 3y squared times 2y, that's 6y squared. 3y squared times minus 7, that's minus 21y. I've got a minus here, and I factor out a 2. So I'm factoring out a negative 2. Negative 2 times 2y is negative 4y. But it's negative 2 times negative 7 to give me a positive 14. Okay. If you ever get to a step where you had 2i minus 7 and you ended up here with 2i plus 7, go look at the signs, because you might have made a mistake in getting that where it needs to be. Okay. So let's spend a little bit more time on some of these. Hopefully they fall into a rhythm after a while. So your strategy, 4 terms, what's the only thing that's ever going to work here? Factor by grouping, okay? So you need to just look at this as 2 separate problems, okay? So if I look at the first 2 things, what do they have in common? 3. So they have 3, and then how many w's do they have in common? Yeah, 3w squared. And now let's just backtrack. What do I multiply 3 by to get 18? 6. What do I multiply w squared to get w cubed? W, okay? Now let's plus sign. What do I multiply 3 by to get 15? 5. What do I multiply w squared by to get w squared? That's just 1, okay? So that's half of it there. Now, whatever the next sign is, what's the next sign? Plus? Copy that down, okay? Now let's look at the next 2 terms. What do 12 and 10 have in common? 2. So if I factor out a 2, what goes in the parentheses? 6w plus 5. And if you are living right, what's in the parentheses is in both places. So now what do you factor out the next step? 6w plus 5 gets factored out. So it's 6w plus 5, and then you just copy down what you're left with. If you factor 6w out of 5 plus 5 out of the first term, you get 3w squared, and then plus 2, and you're done. Yes? No, you could write 3w squared plus 2 times 6w plus 5. Is that what you mean? Yeah, you could do that. Okay. So really, once you get to this step, your answer is going to be this goes in one parentheses, and this goes in the other parentheses. It doesn't matter the order for that. So the next one, again, just look at it as 2 separate problems. What can be factored out of the first 2? Yeah, 2x squared. And so to multiply 2 to get a 6, that's going to be 3. X squared times x will give me x cubed. Plus, and it looks like a 2. So 3x plus 2. Now, what's the next sign that you see? Plus or minus? Minus, right here. So you bring down that minus sign. Very important. That sign you can't change that sign. Now, what can be factored with a 15 and a 10? 5, okay? But you have to keep in mind, I'm factoring out a negative 5 here, okay? So, what do I multiply negative 5 by to get a negative 15? 3. And there's also an x there. What do I multiply negative 5 by that I can get a negative 10? Positive 2, right? And there we go. And so these match. So what's the final answer? Yeah. So 2x squared minus 5 times 3x plus 2. You've done this before. You remember this. You don't remember this. Okay. Is it boring, Cece? Okay. Again, you get tired of like 4. You see 4 things together. Your only hope is what to work. Grouping. If grouping doesn't work, then it may not be factorable. Okay. So what can be factored out of the first 2 terms? 4x squared. And that leaves you with what? 2x plus 1. Now you're hoping that you see a 2x plus 1 later down the road here. Copy down the minus sign. What number is common between 18 and 9? 9. So what do I multiply negative 9 by to get negative 18x? That's just 2x. What do you multiply negative 9 by to get negative 9? Yeah, plus 1. So now your answer is 4x squared minus 9 times 2x plus 1. And now this is where the tricks come into being. Am I done? Why am I not done? Yeah, I've got the difference of two squares, which is what we did yesterday. So just because we did it yesterday doesn't mean it's history. With factoring, you always have to keep looking, can I go further? So how does this one factor? 2x minus 3, 2x plus 3, and then I've still got that 2x plus 1. That's the complete factorization. So we're going to have about 4 or 5 methods of factoring, and just because one of them works, you got to keep the rest of them in your head to say, can I go any further? So every time you see it's something like 4x squared minus 9, when you see two numbers with subtraction, your question always, is it a perfect square? Then you can go further, okay? Now, do I have a volunteer, or do you guys want to work it at your desk? I don't want to put, yes, I will go ahead and say this. If you haven't filled out the survey, please do it. Several of you filled out the survey, and some of the comments, I'll just pause it. Had in common was no number, but they had in common the x squared. So when you factor that out, 2x plus 3, copy that minus sign here. This 2x minus 3, there was nothing could be factored. But what I really did factor, you didn't see those negative signs. You have to put it in parentheses here. So this is negative 2x, negative 3. And then this is x squared minus 1, 2x plus 3. So several of you got to this part. You have made no mistakes, but you've got to have that mental image of like, okay, am I done? Okay, you did grouping, but this is the difference of two squares. So that's factored as x minus 1, x plus 1. Okay, take a look at the next one then, and we'll come back and look at it. So strategy every time is to look at it like two separate problems. What do the first two have in common? X to the fourth, okay? And then what do I multiply x to the fourth by so that I get 2x to the fifth? That's just going to be 2x, okay? What do I multiply x to the fourth by to get x to the fourth? That's 1. Minus sign, copy the minus sign down. Now notice somebody had a common factor. 8 is in common, but it's not the greatest common factor. What's the greatest common factor here? 16, okay? So now you have to look at it. What do you multiply negative 16 by to get a negative 32x? 2x. What do you multiply negative 16 by to get negative 16? Plus 1. Now you've got what? X to the fourth minus 16, 2x plus 1. Everything is correct. I've made no mistakes, but I'm not done. Why am I not done? Yeah, this is the difference of two squares. This is what? X squared minus 4 times what? X squared plus 4, and I still got that 2x plus 1. Again, I have made no mistakes, but I'm still not done. Why am I not done? Yeah, x squared minus 4 is still the difference of two squares. So this one is going to be x minus 2, x plus 2, and then copy down everything else that you had. X squared plus 4, 2x plus 1. Now in terms of factor by grouping, this is the hardest problem you're going to see, okay? Because I had to factor by grouping, and then I had the difference of squares, and then I had the difference of squares again. Okay, so I had 3 different ways. Yes, Corey? Yeah, so what happened when I got to here, this is all perfectly correct, but this can be factored like this, okay? Okay, but now when I get this far, this can be factored like this, okay? So everything else, see this 2x plus 1 just sticks along for the ride every time. This one couldn't be factored. I left it there. So every successive step, I was factoring a different term. Okay. Like I said, this is as hard as it gets. Pardon me? This one? We don't have a formula for the sum of two squares. We don't have a way of factoring it. So the only formula we have is, okay, for the only formula that you have that you can look at is difference of squares. So if you've got two numbers and they're both perfect squares, we got a formula for factoring that one. Everything else is more of a process, okay? But what you've got to always keep in your mind is when you get to a point, you know, you looked at this and you said 4 terms, let's do grouping. We did that. But we wound up with a term that was perfect squares. We factored it and we wound up again with perfect squares, difference of squares. So that's the thing about these problems. You have to keep interrogating, like, what am I seeing? Can it go further? Okay, with the different methods that we have. And that takes us to about what I wanted to cover today. So I can factor the greatest common factor. That's what we started yesterday, but that stays with you as long as you're ever doing factor. You have to know how to find the greatest common factor, because that can simplify something. So that one has to stay there. The difference of two squares. I think it's easy when I give you x squared minus 4 to recognize that as a difference of squares, but you've got to be able to recognize it when it creeps up in step 5 of your problem. Oh yeah, that's the difference of squares, okay? And then factoring anything that has 4 terms to use factor by grouping, which is what we just did a moment ago. So what this leads us right into is your homework for tonight.